Hi everyone. So today we are going to do this linked list problem called linked list palindrome. So what we have to do is simple. So we are given a linked list with a set of numbers. So here it's already given that it has a value and a next node. So it's a single linked list. The next node, so if it's the tail, it will point to null. So it will be the input will be having at least one node. So it we won't be given the head will always contain a node and it won't be a null value. So we need to find the palindrome. So suppose we need to find out whether it's a palindrome or not. So we are given this number. I mean, we are given this linked list. So if how to see if it is a palindrome, if we read it. So if we read it from the left to right, like it's 0, 1, 2, 2, 1, 0. So if we read it from right to left, 0, 1, 2, 2, 1, 0, we get the same number. So it's a palindrome. So we need to find out whether it is a palindrome or not. We need to return it is true or false. In this case, it is a palindrome because if we read from the left and if we read it from the right, it's a palindrome. So we return true. So how do we go about this? So first thing, what comes the brute force approach will be to traverse each of them, get each of the element, right, and store it in the array, store it in one array. So we have 0, 1 to 2, 1, 1 stored in an array, and then in that array we can iterate first from the left to the right. We get one number, and then if we again iterate from the right to the left, we should be getting the same number. So if we don't get the same number, we can say false that it is not a palindrome. So, but this step involves but this involves a lot of things. Like we need to create an array, add the elements to that array, and then we again need to iterate through that array to the left and to the right. Once from the left to right and once from right to left. So the time complexity for that will be often, but we will be iterating to like two, three times, three and something it will be, but yeah, but it comes out to often, and the space complexity will be again often because we are again storing these elements again in we are storing all the elements again in an array list, so it's gonna be often. So we need to do something more efficient. So what we can do is, so how to go about doing this in often time complexity, like within one iteration only we need to somehow come to know that it is a palindrome or not. So what we do is, and we also should create any auxiliary data structure like array list and stuff. So what we do here is so suppose we have this one. So that how to go about solving this problem is we will find out the middle array. I mean, we'll find out the middle element in this linked list. So once we find out the middle element, we have two halves. So in our case, the middle element will be 2, right? So the middle element will be 2, and then what after finding the middle element, so we will reverse this second half. So once we reverse this second half, we get something like 2, 1, 0. So once we reverse this, we'll get something like this. This one will point to null. So we need to reverse only the second half, and we'll get something like this. So after that, after reversing, we can check like now we have both the parts here. So we can check if 0 is it equal, yes. So 1 is it equal, yes. 2 it is equal, yes. We can go on checking until until the second point array of this until the pointer of this reversed linked list will point to null. So until first we check these both, then we check these both, then we check these both. Uh, we need to go on until this reversed array pointer will point to null. So yeah, or else if it points to null, yeah, it is a palindrome. But again, if one of these numbers don't match, we can immediately return false. So that's the that's how we are going to do this one. So that's the trick. So now I'll just write down the steps here. So what we do here is, first thing, step one. So the find the middle element, right? Next, step two, find reverse the second half. And step three, iterate on both sides until until second half pointer points to null. Then return true. If one of the numbers don't match, then return false. So that's it. These are the steps. So we will understand what this third step means when we are going through the code. So now let's start coding. So one thing what we can do here is, before we start coding, this time complexity will take an O of n time. So it will be time complexity will be O of n, and the space where n will. So we need to iterate at least through each of the things in the at least through each of the array elements. So it will take O of n, and the space complexity will be O of 1, because we won't be using any extra space. Actually, the time complexity will be O of n by 2, because we need to iterate till the half of this one. But then, yeah, n by 2 is half. We can take out the constant and it will still be n. So this is the time and space complexity. So find the middle element. I have created a video about this one. So we use the two pointer technique to find that in an efficient way. So that's what we are going to implement here. I've already created a video, so you can check that out. I'll implement the same thing here as well. So first step, let's find the middle element. So let's go here. So let's just write it down. Find the middle element. So next, link this. This linked list slope pointer is equal to head. Linked list fast pointer is also equal to head. So while fp is not equal to none, and p dot next is not equal to null. If so, a slow pointer equal to slow pointer dot next fast pointer to fast pointer dot next. We'll keep slow pointer. So what we are doing is we are keeping one slow pointer and fast pointer. So slow pointer will iterate once, but fast pointer will iterate two times. So in the end, the slow pointer will be having. So we are going to iterate until the fast pointer reaches the null or next dot null when the numbers are odd. So total numbers are odd. So we come till here. So this India the slow pointer will be pointing to 2. So yeah, so that's how we find the middle element. So slow, just check it. System dot middle node is equal to sp dot value. So let's run it. So in our case the slow pointer is 2, so the middle pointer will be 2. So now we found out the middle element, we did the first step. Now we reverse the second half. So all we need to do is we need to reverse the second half. So for that one, we know the middle SP will be pointing to this one, right? SP is pointing to this one. So I'll take, let's write it, reverse the second half. So once we for that, yeah, so slope pointer will be pointing to the middle node. So I'll just put previous pointer where we use for reversing. So reversing also you can check my video. It's there. So I'll put linked list p1 is equal to null. So then put linked list p2 is equal to sp. So this is, yeah. So now let's write the code while p2 is not equal to null. We'll create a temp linked list temp is equal to p2 dot next. So next p2 after that we will do so we have something like this. This is null. So we have P1, P2, temp. So P2 dot next will point to P1, P2 dot next is equal to P1. So P2 dot next will point to P1. Okay. Next, after this, P1 will be P1 will should come here. So P1 is equal to P2 is equal to P2. Next, P2 is equal to temp. P2 is equal to temp, and temp is equal to temp dot next. P2 is not yet null, so we put temp is equal to temp dot next. P2's dot next will point to P1. Yeah, so just to so after reversing, so P1 will now be here. P so P1 P2 is equal to temp. P2 temp temp. Next, P2 dot next is equal to P1. P2 dot next is equal to P1. Okay, P1 is equal to P2. P1 next P2 is equal to temp. So P2 is pointing to null. We exit. So in the end, we have P1 is like this. We'll have P1 pointing to 0. So P1 is now pointing to 0. So if we do system P1 P1 dot value, so P1 dot value in our case should give 0 plus p1 dot value. Mm, So p1 dot value is giving 0, so we have reversed it properly. So now all we need to do is we need to iterate both sides. So p1 we have, here we have a head. So we have pointers to both sides. We just need to check if both sides are matching or not. So first we'll check 0 0, next we'll check 1 1, next we'll check 2 2. If we are matching, it will return true or else will return false. So while, so like I was saying, we need to check for the p1 pointer until p1 reaches null. So while p1 is not equal to null, p1 is not equal to null if p1 value is equal to so we have this head, right? So we'll call it linked list first half is equal to head. Should not lose here the head. So this is the first half pointer. First half. So we created this one. So if p1 dot value is equal to p first half dot value return true, else return true. You don't have to wait. If it is not equal, so we are checking. So if in case if 0 0, okay, they're equal. If in case this and this is not equal, so if it is not equal, we need to return false, right? We can immediately stop this loop and return false. So if they're equal, we need to move on and check for the next one. So we do p1 is equal to p1 dot next, p2 is equal to first half is equal to first half dot next. So if we come out of this loop, if we reach till the null, okay, we come out of this loop, it means this is a palindrome. So if it is a palindrome, we can return true in the end. So yeah, so guys, this is the code and these are the steps. So let's run and check. So yeah guys, so this is how we do it. So and space and time complexity will be O of n and O of 1, like I have mentioned here. So that's it guys, thank you for watching.